Hello, AMC students. So just a couple more video requests that people were asking about. One was about problems involving the ln or the e, and I just want to very briefly remind you of where that number comes from, and then we'll deal with how we actually handle it in a problem. So if you remember our compound interest formula, sometimes we write it with different letters, but it's basically the amount of money you have is your principal times 1 plus your interest rate raised to the time. But what happens when we compound it is instead of paying the interest rate every 1 year, we pay a fraction of the interest rate. So you divide by the number of compounds and you pay it n times per year. You need to have the letter n in there twice because you're both paying a smaller amount of interest, but you're paying it n times throughout the year. And that's what the idea of compounding is. Now, if you take a $1 initial payment, initial amount, with 100%, so just the number 100% interest over n time, and if you do it for 1 year, it turns out that you get paid more and more money the more times that you compound it. If you only compound it once, you get $2. If you compound it twice, you get $2.50. And if you compound it more and more times, you get more and more money. But there's a limit. And the way that this works is you have this value approaches the number e. So as the number n becomes infinite, meaning compounding it every second of every day, every split second of every day, infinite number of times, it comes to e, and that is pretty close to 2.71. And so the number e is similar to the number pi. It's a symbol, it has meaning, it's a ugly decimal, but it is just a number, it's not a variable. And just like you get the number pi from this natural thing of dividing a circle by its diameter, you get the number e from this sort of natural question of what happens if you compounded it an infinite number of times? It turns out you get the number e. Now, the number e is so common in math that instead of writing the log base e, we write ln, and that stands for the natural log. You can switch back and forth. I don't care which notation you use. They are equally relevant and useful to me. So I'll just do a couple quick examples, and you'll see that it's really just a number. You treat it like any other logarithm. So let's say I had ln of x minus 5 is equal to 2. And I'm trying to solve for x here. Well, I know that ln really means log with a base of e. So I can just erase, just cross off the ln, and I can think of it as log with a base of e. Okay? Then what I can do is raise both sides as the power of e, because logs and exponents are inverses. And so that just gives me x minus 5 equals e squared. Solve for x just by adding 5. X equals e squared plus 5. You can calculate that if you want, but there's really no point. If you calculate it, I think you'd get an answer of like 13 or so, but you can leave your answer in terms of e. You will remember in geometry class, you often left your answer in terms of pi. So that was one example of solving an equation with an ln in it. Nothing to be scared of, it's just a log with the base of e. Similarly, if you had e to the 2x plus 1 is equal to 5, I know that e has a special logarithm that I can take both sides, the natural log of both sides to cancel out the e. Then I have 2x plus 1. Sorry, that looks like an h. It's ln of 5. Then I'm solving for x just like we normally do, minus 1 and then divide by 2. So I have x equals natural log of 5 minus 1 divided by 2. Don't try to combine those pieces together. Just leave it like that. ln of 5 minus 1 over 2. That's going to be a decimal of some sort. So there you have it.